simple examples. Suppose you go to any grocery shop and you request to the grocery people that give me the toothpaste, etc. For all the order you made to to the grocery shop, they keep on recording all the transactions. So the same things they do for the different customers. As day grows, they have a different kind of transactions at their leisure. So they also sell the products to the consumer. They also buy from the wholesaler. So they keep recording into the in somewhere else in their notebook, in the computers, all the way. That is nothing but a ledger. So a ledger can have millions of transactions. So these million of transactions are stored into the block. So you can see here we have you can see on the screen that the blocks are linked each other using the link here. So I said ledgers, the millions of transactions are stored into the blocks, are interconnected, interlinked with the link. So if you have studied the data structures, and the data structures you have studied the linked list, where the nodes are connected with another node using the pointer link. So likewise here also one block are connected with another block connected with the flowing blocks using the link. So how these blocks are created? So block has a size. A block size is 1 megabyte. So if transactions that use 1 megabyte and transactions increases more than 1 megabyte, the rest of the the rest of the transaction goes to the another block. Then again on another block occupy the 1 megabyte, then rest of the the transactions go to another block. So this is the way the blocks are built, and then each block are interlinked with this pointer. So when blocks are the transactions are stored into the blocks should be protected. So the Bitcoins has some like a security mechanism protocols to avoid a fraud. So this purpose we should dive into the cryptography. So a cryptography and hash function. So Bitcoin mechanism says that blocks should be protected using the cryptography hash function. So question is that what is the cryptography? So let's go and understand what is the cryptography or hash function. Understand using this function called the square. So square is a function has one parameter called the x. So we need to guess a x value that returns a square of that. So 16. So what could be the value of x that square is 16? So we can guess is a 4. So it is an easy guess. Let me take you another examples. We need to guess a value of x and y that result sum of x, y, which is a 9. So we are going to guess x could be 4, x and y could be 5. X could be 5 and y can be the 4. Likewise, x can be 3 and y can be 6. So this guess can be keep on guessing until your guess matches. So here little difficult. Fine. So let us see another example called the hash function in the cryptography. So SHA-256 has one parameter x. So we need to guess a value of x that returns this this hash code. This hash code is truncated. I have not written all the 64 digits here. Just I have removed. That's why I have written a dot dot dot. So if I ask you to give me a value of x that returns this hexa, this hash code. If I see, okay, what could be the value of x2 that returns this is a hash code of this x. This is a close to impossible. So this is a cryptography. This is a cryptography security mechanism of the Bitcoins. So let's understand more. So if I have used this Kundan is a text. If I pass this Kundan text to the SHA-256 cryptography hash function, then it returns 64 digits long hexa code. This is a hexa code, hexadecimal code. So to get this hexa code, I have written a 3-line Python program. 3-line Python program you can see on the screen. Fine. So we will see this one in the practice as well in the coming, in the few minutes. So let's go ahead and see. This is a cryptography. So let us understand, the block component in the Bitcoins. So the Bitcoins is the transactions. We have a different kind of transactions, and transactions are stored into the into the blocks, and the blocks are protected using the some security mechanism. That's I'm talking about the hash functions. So now we should know how to how to create a new hash. So before creating a new hash, you can see here, before creating a new hash, we need to know the different component of a block. So look at this one. A block can have a block number, block can have a transaction, and block can have a previous hash, and then nonce. What is the nonce? Nonce is the nothing but only used one times number that to create a to create a new hash, means number of times that you are guessing to get a new hash. So here nonce means, suppose I'm using nonce once to get a new hash, and the new hash that you are guessing is not like getting approval, then we'll use another nonce 2. Then again we'll create a new hash. Then nothing, nonce is working like looping. So the number of repetition you are using. So fine, to get a new hash. So the block number, transactions, previous hash, and nonce is a component of the block. To get a new hash, we need to have this parameter. So let's go into the coding part. How can we the cryptography can be implemented using the Python? So now I am here, you can see. So first of all, we need to import some hash function. So we are writing here the hash lib. From hash lib, please import a import the module called the hash SHA-256. And then taking to the simple example, I'm writing txt, then Kundan is my name. I'm going to encode it using the hash function called the SHA-256. So I'm going to print and in SHA-256 text, please encode it and then print it. So let me see how what it returns. So when you print this one, it's just printing some object here, you can see here. But I want to print some hexa decimal things. So I am going to write it here as a dot hexa digest. When I print here, then it will print 64 digits hexa decimal number for 64 digits. So here not easy to guess. If I will give you this hexa hash code to you, and I will ask you, can you guess that actual number, actual value of this hexa code? It's not easy to guess. Fine. So that's why let me copy and paste and keep it somewhere else for further use. Might be I need to use this one as a previous hash. So I'm just storing here as a comment. So now I will take you to the now we can make it a bit a professional code using this one. So let us define some utility function called the SHA-256 as a function that takes as a string and returns something. So I'm going to delete this one because I'm going to make a bit of professional code here. So we need indent here. So now return this hexa code. Now, since we are writing, we have a main function here, main file here, that main.py. So let me write if it has a the name equal to that the main, so call this one. So I'm going to call, sorry, something is missing here. What is the missing? The underscore. So now you call here something like a txt equal to Kundan. Now let us change this time. I'm writing like a xyz, simply xyz, and then call the function called the sha and pass this text. Since this function returns something, you can see return something. So we need to create a variable that nothing but new hash and store into that, and then print that new hash. Okay, run this one. You can find we have another new hash code that is a for xyz. Fine. So this was a simple how to use the SHA-256 function, hash function of the cryptography here in the bitcoins here. So now we are going to define a new function to mine the new block hash code. So new block hash code. So before going to that, we need to know I'm writing the past because I'm not going to define the function now. Just first, before going to mine this one, we should know what is the component of a block once again. So I will take you through the presentation. So this a block component is here. So a block has a block number, transactions, previous hash, and then nonce. So we need to have this parameter. We need to pass this parameter to that function that we are creating right now. So we are going to mine it here. So before mining here, what I mean to say, let us create that transaction first. So first of all, we need to have a transaction. So guys, let me delete. Okay, let it be this one. And as a simply, so transactions equal to, then we have a string here. Then we write here might be something Kundan. Okay, here we can say Guru stack to Arvind to $90, comma, then Arvind gives to Kundan $80, then Kundan gives to someone XYZ simply $20. This is my transactions. Is it look like the transaction that you have seen in the block? So now this is a one, and we need a what? We need a block number. So suppose we have a block number. We are guessing a new hash for the block number might be 6. Just an example. Now what we have a now transaction. We need to have a previous hash. So just we are guessing here simply. So just purpose, I told you at the beginning, I must copy paste this one. I must have this one. This is a simply one previous hash code. I have it now hard coded. I'm just hard coded. It should be dynamic, but here we are doing the hard coded. Now we need to have a nonce. So nonce I will use as a here hard coded within a functions. So I will take you another presentation here. When we are talking about the guessing a new hash for the new block, the difficulty is very important. Difficulty is very important. In examples here, I'm taking first 0. What it means, when we are creating a new hash, the first 4 digits should be 40 only. So if I say to get it, so what happens if difficulty increase, the computation time the system takes more and more. Suppose I'm saying, okay, I'm guessing 1 times. No. Suppose I'm guessing 1 times. Did I get new hash with the 4 digits 0? No. Guessing 2 times. Did I get a new hash with the 40 big prefix 40? No. Then like that you have to. So nonce is nothing but repeating the number of times. We are guessing the new hash with the difficulty level. So what is happening here? Miners write the code like the one we are writing here. The miners write the code and keep and guessing by using the trial and error method to get the new hash with the X number of zeros. So that is the use of nonce here. Okay. So once the miners guess the right guess, then that will be rewarded. So who gets the rewarded? If you have a 10 miners, and the 10 miners, the first miner who gets the first will get rewarded, and the following miners, even though they guess the right, they will not get rewards because they have done bit late. So that's why we need to have high computing machine, like a high speed internet, high speed processor, a big data storage, and many more. So we have a different kind of machine available in the market that we can buy and can become a miners. Okay. So let us come back to the points here. So we are talking about the difficulty levels. Okay. So for here, let us go back to the code here. I'm writing here. So here I'm writing here like a difficulty, because this difficulty keep increasing. I will tell you later on what is the difficulty. For here I'm taking currently difficulty level is 20, means here the prefix 0 is 20 now. At the beginning it was a 4 or 2 or something like this. When the bitcoins started, the very first time. So let us go. This is our components, transactions, block number. So let us put it like order doesn't matter. Simply the way I'm just trying to depict the the picture that I have done it. So block number, then transactions, then previous code, then difficulty level. And then we need what? Nonce. So nonce I will use here in the function mine definition. So now here what we have to do, so since we have created here nonce here, we need to pass this one as a parameter to the mine. So I'm going to call the function, I'm calling mine, mine function. Okay, so it's a comment, so let me put it the comment as a comment. So finding mine, so mine has a parameter. What parameter? Block number, comma, transaction, then we have a previous hash, then we have a, this is not part of that then difficulty. So once we go there, this is the things we can copy paste here, just copy paste here, same, just to save the time. We can copy paste because this is a function definition. Find difficulties. So now we have here, now we can give the here as a, so we can create here hard coded nonce is a 1. Okay, nonce is a 1. So again I will take you to the block. So now we have to create and make a string that has block number, transactions, previous hash, and nonce. So I'm going to make that string here str, or we can say txt equal to block number, that which we are passing to the this function as a parameter. So block number is a number, this is a number, so we need to convert as a string str, then concatenate using the plus. Then we can go for the what? We can go for transactions. Transactions is a string. You can see this is string, so no need to typecast. Then we have a previous hash. Previous is also string, and then not a difficulty is a nonce. So nonce is also here is a string. So this one, this nonce is a part of the block. So we can put str and convert into the string. So this is a bring a string. So this text should be encoded using the hash function. So we need to call the function called the hash. So SHA-256 and pass this text. So this function returns something. This function returns. So this function brings something. So we need to have some variables to hold that. So we are writing the name called the new hash. Okay, so new hash, this one is done. So after that, once new hash done, so is done, then we can also, this mine function can return new hash to from where it was called. So this new will, now here I'm talking to say here we need to change this one because we are progressing here mine. So not here because we are calling the mine function, so we can create a new hash. Then so this function returns, now we are printing the new hash. So we have a two function, one is SHA-256, and then we have a mine. This mine is nothing but we are we are mining and trying to guess the new hash for the new block. So let's run this program and we see a new hash code has appeared here. New hash code is, so we have done it here for these transactions, and for the block number 6 we have done it, but we have not used the difficulty level. Let me tell you what is the difficulty level. Let me take you to the blockchain explorer. This is a blockchain explorer. Let us go back back. Okay, you can see it's taking time. Go back. Yeah, fine. You can see here I'm on the blockchain explorer bitcoins, the home page. You can see the latest block that they have created. The latest block they have created here, you can see here is a 72,034,122. Sorry, what happens? Currently, I'm just in an example, I'm taking 4 difficulty 4. So I want to show you what is the current difficulties here. Here you can see this is a new hash for that block that you have seen here. Block number, height is nothing but a number of block. So this is a number of 0 at the beginning. This is a difficulty. It could be 19 or 20. Okay, so who have done this one? It is done by the miner name is Antipol, and it has done by the how many nonce have taken. This is a nonce. How many nonce have taken? Is very big nonce have taken, and for that he was rewarded at this many coins. So every 4 years the reward is divided by 2. Every after 4 years the reward, the bitcoins reward are decreased by by 50% down. So we are not talking about that one right now. So we are talking about the hash. So this is the difficulty level. If you go to the block one, if you go and check the block one, let's see here. Let me see what happens here. Let me see what is coming here, just to show you block one, the block first. Let me see this Explorer block 1. So you will see the difference, what I'm talking about, the difficulty. You can see here in the difficulty level, in the beginning here is just like a 10 or something. How many there? 1, 2, 3, 4, 5, 6, 7, 8, something. 8 bits, I think. 1, 2, 3, 4, 5. Yeah, 8, 0. For the very first block, it was 8, 0. Can you see here? And but for the current one, just now they have seen it has become more close to the 20 or something, isn't it? So this is difficulty level we are talking about. So in example, we have taken here as just a difficulty 4. You can increase, you can make it. So here we are taking hard coded, we can increase the difficulty. So fine. So these two we are going to get. So now here we have done it here, new hash. So now we have to think, no, I want a difficulty 4 means we want, we want here like comment 4 zeros in new hash. How to do that? So for that purpose, we need to, use this difficulty. So for that purpose, I can show you how to use that one. So let me take you the console and teach you something here first. I'm here, I'm writing here Python. You can see here in the Python, I'm writing here txt, I'm writing here something. Let me use this hash code, simply copy and I paste it in this one. Okay, and then come and then write here txt dot, there is a function called the starts with. I'm saying this number start with 4 digits, then it will return true or false. False, then returns false. This is because, let me take it a bit bigger. This is because this text has a start with the 257 something, not by 50. Then I can, let me add few zero here. 1, not here. Okay, let me do again here. Let me add few zero here. 1, 2, 3, simply, and then run again this function. This start with 4 0, no, false, because it start with only 3 0. So let me change here, start with the 3 0. Then you can see that we are true. So I'm going to use this function here in my code. So how to do that? I will show you here. So first of all, difficulty is coming in the difficulty here. You can see here in difficulty. So I'm going to use the prefix 0 equal to, we are going to concatenate 0. How many times? The number of times difficulty we are sending. So I'm using the difficulty 4. So what will happen? I'm using the string concatenation repetition. So 0 is a string here, I consider as a string, multiply 4 times. So it will become 4 times. If it becomes 6 times, then it will become 6 times automatically. So that is a difficulty times. We are going to increase it here. Fine. So we have prefix 0. We have done it. So now we are going to run this application and check. So we have to check here new hash. If new hash starts with which one? Prefix 0. Prefix 0. If you start with this one, then return new hash. Okay, I run this application. What is the output? Output error. Let me see where is the error. Okay, we need this one. Let me run again. Double colon was missing. None. What happened? I run only one time. So one nonce 1. Again we run. So it might be the second chance. Then again 1. Say third time, fourth time, fifth time. So we are keep on clicking on the run and check the new hash, whether the new hash has that start with the 40. That is the condition I have put it here. Can you see the prefix 0? So fun, what happens? We don't have a stamina to keep clicking and sit here. So we have to write an instruction and command algorithm that computer does automatically for the certain number of times, because you have a computational machine and you have a time. So you can give the command to the computer, please execute this set of instruction for certain number of times. So for that is nothing but a looping. That's why I was talking about the nonce is nothing but a kind of looping here. So I'm going to do what? I'm going to use the looping to use there. So I'm going to write here for nonce in range. This range gives the large enough that computer keep on trying to get that hash that start with the 40 and with the prefix. So I'm going to put inside, because for nonce each time we need nonce. So very first time it will come, it's like a, so here something 1, then it will come 1 here, then 2 here, and each time you create a new hash, you keep checking that new hash has the prefix 0, that the one you have created here, this one. If yes, return that one. Okay, so let me try this time. I'm running this one and system is taking time. It depends. System can take a long time, 1 hour, 2 hour, 30 minutes. It depends to get that hexa code that has a 40. So now you can see this code has a 40 here in this output. You can see here. Here you can see, guys. You can see here. This is a 4-bit here. First 4 is a 40. You can increase the difficulty level here. Might be you can say 20. So if you increase the difficulty level, the computing time may also increase. It can take 1 month, 2 months, 3 months, depends, to get that hexa code that has the 20 at the beginning. Okay, so for now I'm not just clicking, simply I'm leaving with 4 difficulties. Okay, so now here we are going to say, so I want to check it out. So simply creating. So I want to print what number of nonce that has system has taken to get this new hash. So I'm going to print that nonce here. So print, then f print number of nonce taken by system. So you can put it in that nonce here. Okay, done. And let's see what happens here. Okay, you can see 10,098 nonce taken to create, to get this new hexa code, guys. So this was a code to mine. So we are guessing the new blocks nothing but this hash code is nothing but a new block. A new block has this transactions, a block number, transactions, previous hash, and the nonce. So nonce is the one we are using here as a loop. Okay, so this code can be improved more and more. You can calculate the number of times has taken by the system to get this nonce. We are talking the nonce. We can also take how many seconds taken by the system to get this new hash. So here that the first person to get, to guess the new hash code with difficulty level to get rewards. If you have a 10 miners and any first miner get this, this new hash code with difficulty levels, get rewards. Rest 9 will, if they guess as well, if they are not the first one, they will not the rewards. Okay, guys. So this is the one. This much only for the day, and I would like to, conclude the sessions. Today we have learned what is the Bitcoin, what is the ledgers, what is the the ledger is a set of transactions. We have learned what is the blocks. Size of the block is 1 megabytes, and the transactions are stored in the blocks. And the Bitcoins has a security mechanism called the cryptography and hash functions. And we have seen what is the hash function. We have defined the hash function, and then we also have done the prediction, like guessing the new blocks and the new hash of the block, and then we have done also we have implemented using the Python. So hope you have liked these sessions, and okay, I'm looking forward to have your feedback to improve the the coming sessions. So thank you.